Hi everybody, Patrick here from EngineeringShock.com, PaintballProps.com, and EscapeRoomElectronics.com. This is the Arduino Playbot, project number 7. The Arduino Playbot Kickstarter Campaign is linked below in case you're interested. And for this project what we're going to do is we're going to create a motion-controlled alarm system. It's a fun little project and it's easy to hook up. So let's talk about our hardware hookups and then we'll give a demonstration. On the bottom left of the board is a 3-pin header which we're going to use to connect to our passive infrared motion sensor, our PIR sensor. There are 3 pins, 5 volt, AD for analog to digital, and GD for ground. So what I'm going to do is I'm going to take my 3-pin cable and I'm going to connect it with the red wire facing left and the white wire facing right. Just like that. On the underside of the passive infrared sensor, we've got a 3-pin header, VCC, which is 5 volts, out, and GND for ground. So we're going to want to connect our 5 volt line to the VCC line, so a red wire here, and our white wire to GND. Like that. Now what we need to do is turn on our LCD. We're going to remove our enable jumper, which forces the backlight of the LCD on, and because we're actually using the software-controlled backlight controller in this project. So GPIO 10 will control the backlight. So these are the 6 LCD control pins, GPIO 4 through 7, which control the RS pin of the LCD, the E pin for enable, D4, 5, 6, and 7. And we're actually going to use the backlight control bit, controlled by GPIO 10, and turn that on. Next what we're going to do is we're going to switch on the middle dip switch right here labeled BUZ for buzzer. Now as soon as we power on, we're going to enter into a passive infrared motion sensor calibration mode. What I've done is I've mounted my passive infrared sensor, or rather I'm just got it clipped onto a little helper here, and I'm going to leave it so that it's facing away from me. Now the passive infrared sensor picks up the infrared spectrum coming off of the human body, and it has 2 outputs, high, 5 volts, and low. Some PIR sensors have a 3 volt output when it's high, but that's okay because the good old Atmega 32 APU chip considers that a set line. So 3 volts or higher is a high, and 0 volts is low. And so what we're going to do is we're going to power up the module. We're not going to worry about the PIR sensor right now. We're just going to power it up. Now, I know the LCD might be a little bit difficult to read. So what in the starting out state, it says PIR state, low. Now, for the first 30 seconds or so, when you power up your PIR sensor, it's in a funky state. It needs to settle. So go grab yourself a sandwich, or even just use the bathroom. And by the time you come back, it will be ready to go. So right now what it's doing is it's reading the state. The software is reading the state of the output of the passive infrared sensor. When you power up, don't worry if placing your hand in front of the sensor doesn't cause it to change states. After 30 seconds or so, what it should do is it should read high when you place your hand in front of it. There we go. It went from high to low. And it might double trigger. There we go. It double triggered. So it's still not in a steady state. So 30 seconds or so later, eventually what's going to happen is it's going to read low by default as long as the PIR sensor isn't pointed at you. And as soon as you place your hand in front of the sensor, or even a few meters away, it should read the LCD should read the state. So it's relatively good right now. It's in a good state. So what happens is as soon as I press this button right here, the cell button, what happens is the LCD will turn off, and from then on, every time the output of the sensor reads high, 5 volts or 3 volts, the unit considers motion detected. So I've given the PIR sensor time to warm up. Now what I'm going to do is I'm going to press the cell button, hold it for a moment until the LCD turns off. We'll end up in the scanning state, at which point, whenever the sensor detects motion, the buzzer will go off. So, and it will beep. Beep, 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 beep. So what I'm going to do is I'm going to press the cell button. LCD turns off. It's now in scanning mode. So if I place my hand in front of the motion sensor, we'll hear beep, 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 beep. I'm going to give you a better view of this in just a second. Break the sensor. There we go. So I'm standing about 4 meters away. The PIR sensor is not aimed at me, and I'm going to start walking through the room. now I'm at the other side of the room. I'm being still, and I'm going to walk back. And there you have it. So as I'm standing in front of the PIR sensor, as you can see, it's consistent. It's constantly changing states because it's picking me up even in the dark. So I'm going to move away just so that it's not constantly changing. But to give you a better idea, the LCD looks great to the human eye. My camera seems to have some trouble picking it up, and that's partially because of my room lighting. So I apologize for that. That's why I've got the lights turned off right now, just so you can get an idea. Now this code is extremely simple, but it's fully commented. Those who pledge towards the Kickstarter campaign will have access to all of the sample code that's fully commented at the end of the Kickstarter campaign. So thanks for watching. It's a very, very simple project, but I wanted to introduce you to the Playbot with the motion sensor and the calibration software, because we're going to be using the PIR sensor in the future for future projects to prank people with the infrared receiver and infrared transmitter on the Playbot. Thanks for watching, everyone.